This video covers topic 15.4 over converting quadratic functions. The transformation form of a quadratic function is f of x equals ax minus h squared plus k, is also said to be written in vertex form. On your formula chart under quadratics, because that's what we're studying, we talked about standard form last unit. We are talking about quadratic form in this unit. So you do not have to memorize this. You just have to know what a, h, and k do. The vertex of the parabola is listed at the opposite of h, comma k. The line x equals h is the axis of symmetry, and the maximum or minimum value is k. So they tell us if f of x equals x squared, write the equation of the new function g of x under the following transformations. So they want us to shift this f of x, which is x squared, to the right 4 units. To write that, minus 4 needs to go inside the parentheses with x. Now they ask me which function is equivalent, and all of these are listed as though it has been multiplied out. So we've started a box for you, and we're going to finish it. So remember, we do top times side, x times x is x squared. Negative 4 times x is negative 4x. X times negative 4 is negative 4x. And negative 4 times negative 4 is a positive 16. So I take these two and combine to get a total of negative 8x. So my equivalent function is x squared minus 8x plus 16, which is answer choice C. So today we are taking and writing our equations and then figuring out what is equivalent on the other end. Problem 2, they want me to shift the vertex of f of x, which remember that means x squared, to 5, negative 3. Remember that your vertex is always the opposite of the first number and the same of the second number. So to write this, I need to do the opposite of the first number and the same of the second number. So x minus 5 squared minus 3 would shift my vertex to 5, negative 3, because this is the opposite, so it would go to the right, and this is the same, so it would go down. To find, again, the equivalent function, all of these are listed as they've been multiplied out. So I take x minus 5 and square it, so x minus 5 times x minus 5. Top times side, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Combine my like terms. So I have x squared minus 10x plus 25. Now remember that piece in red is just this multiplied out. We also have the minus 3 to factor in. So when I combine my like terms, 25 minus 3 is 22. So that answer choice looks like B. So again, all we're doing is multiplying it out, and then if there's anything in the front, in the back, behind, whatever, we have to factor that in. So problem 3 asked me to reflect it across the x-axis, shift it up, and shift it to the left. So f of x is x squared. In order to reflect it, I need a negative in front. I'm going to do a little color coding here. To go to the left, I need a plus 6 in parentheses. And to shift up, I need a plus 2. Now, when you're looking at which function, we can multiply it out like we did up here. When you multiply it out, once you've boxed this out, you have to change the signs to negative and then add 2. And some of you might have already been thinking 1 and 2 were a bit much, and we're asking you to do more. So a test-taking strategy is once you write this, put this into y1 in the calculator and y equals, and put your answer choices in y2 and figure out which of them are the same. So I'm going to show you how to do that. Now the first thing I want you to notice is we know that in order to reflect, you need a negative in front, and neither of these two have a negative in front, so I can get rid of that option. So what I'm going to do in y equals is plug in my vertex form. So negative parentheses x plus 6 squared plus 2. Now my two answer choices are A and B, so I'm going to plug in A first. Negative x squared minus 34. When I click graph, if they are equivalent, equivalent means equal. If they are equal, it means my graph should end up one on top of the other. Now for this, I need to zoom out a little bit because I know a minus 34 means it's way out there. Now, it's kind of hard to see, but if you look, we have a graph right here and then another graph right here. So we have one here and another graph here. So this is not the same thing. Okay, so now I'm going to look at option B. So minus 12x minus 34. And when I do, excuse me, zoom 6, when I do zoom 6, there's only one graph listed, so that would be answer choice B. Now, just to show you, we've already said C and D, there's no way they could be it. I'm just going to show you what it would look like so that you can see it, because the other ones weren't super great examples. So, like option C, if I graph these, see how I have two very different graphs? So that's not at all what I need. So there's no way C is correct. So you are looking for, when I put in my vertex form and I put in my answer choice, which one only gives me one graph. 4 asked me to translate the axis of symmetry, write 7 units and stretch by 2. So we put the 2 in front to stretch. And then to change my axis of symmetry, that changes your x value. To go to the right, we need a minus, so we put minus 7 in parentheses. So in y1, I'm going to put in x minus 7 squared. Now in y2, we've knocked out b and d because if I do 2 times x squared, there should be a 2 in front, and b and d do not have those options. So a is 2x squared minus 28x plus 98. Now when I look at that graph, it looks like there's only one. Let me zoom out once. So I can only see one, and I'm not seeing anything else pop up. Let me look at the second one just to be safe. So 2x squared plus 49. When I click graph, I'm not seeing another one. Let me zoom out just to be safe. Oh, look, there it is. So I have one here and then one way up here, so they are different. So C is not my answer, therefore A is. Okay, so again, some of these you're going to have to use the zoom function, so just make sure you're zooming in, zooming out. Remember, zoom 6 will get you back to normal, so I'm going to write that up here. Zoom 6 will get you back where you need to be. So 5, 6, 7, and 8 are asking me to determine the vertex, axis of symmetry, max or min, domain, and range. So we can kind of do that without using the calculator. However, know that if you are really fluent in the calculator and really good at those steps, you can use that. So my vertex is always the opposite of what's inside with x, the same thing as what follows. So x is the opposite, same y. Axis of symmetry is x equals 5. So x equals the x from the vertex. Problem 6, they are asking me if I'm going to have a minimum or maximum and then ask me for the value. So I will have a maximum. I know that because there's a negative, which means it's going to be flipped. And my maximum value is going to be that 4 because it's going to go all the way up to 4, and that's part of my vertex, and then it's going to flip. Domain for all quadratics is all reals, and then because this is a maximum, we would have a less than 4 value. Problem 7, my vertex is always the opposite of what's inside with x, so the opposite of a positive is a negative. The same as what follows. If nothing follows, it's a 0, just like if there's nothing in the parentheses, it's a 0. My axis of symmetry is x equals negative 4 from the vertex. Problem 8, if there's nothing inside with x and there's nothing that follows, your vertex is going to be at 0, 0. This one will be a minimum because there's no reflect. My minimum value is that 0 from the vertex. Domain is all reals, and range is greater than or equal to 0 as well. Problem 9, we're given a graph and asked to find the vertex and then see which of these is the same. So here is 0, 0. I go to the left 3 and down 1. So my vertex is at -3, -1. Remember that when you write it, your vertex is always the opposite of what goes inside here. So we see a -3, I need a +3. So that marks out B and D. The -1 should be the same, so that's good for both of these. They both have negatives, which is good because I need that. Now we're looking at a -2 or a -3. So I'm going to put one in my calculator, see what I think, and then look at the other one. So -3 parentheses x plus 3 close parentheses squared minus 1. And I'm going to do zoom 6 to see it normal. Oh, that looks pretty good. It's not bad. Let me look at C. -2. Oh, that looks pretty good too. So if you're looking at these and you're still not sure, remember that we can use our 1, 1 pattern from the vertex. So from my vertex, if I go out 1 over 1, it does not follow. I really go out 1 up 2, which means it is being stretched by 2. So C is my correct answer. Now, one thing you could do is plug these in and see if the point -2, -3 is in your table. So we have the correct answer in y equals. If I go second graph, -2, -3 fits. If I change that to a 3, my graph still looks good, but when I go to my table, the value for -2 is not -3. So that's another way you could use the calculator. Problem 10 asks me which of the following graphs has the vertex of -10, 0 that passes through 160.5. So I can see this needs to be the opposite. So +10, +10, C and D do not match. The vertex would not match there. So no matter what I'm thinking, it's not C or D. From here, we're going to put these in the calculator and look in the table for my point. So that's kind of the easiest way to do this. So for A, I have 2 parentheses x plus 10 squared. And I'm going to go to the table. I'm looking for when x is 1, y is 60.5. So A does not look correct. So I go to B. I need a fraction of 1/2. Delete that 2. X plus 10 squared. Second table. When x is 1, y is 121 divided by 2. 121 divided by 2 is 60.5, so B is my correct answer.